All right, so leave a little space on your notebook because I'm gonna add some more notes in here. So start maybe about a quarter of the way down. What I'm gonna first do is define what element is. So when we are talking about an element, we're talking about something that is composed of atoms. That have the same atomic number. I'll fix it. So that's the first thing that we are thinking about for today is what is an element. I want to give you guys some more context to some of the vocabulary though, just in case, and also just as a nice little revision. So when we are talking about atoms, we are talking about the smallest unit of matter. When we're looking at that small unit of matter, there's several things that make up an atom. The first thing are protons, which are positively charged. Neutrons, which have no charge. I'll just write an N for a neutron. And then the other thing that we have are electrons, which are in the outside of the atom. So that's a general kind of structure of what we talk about when we talk about atoms. So over here we have in the center of our atom the nucleus. The nucleus is made up of protons, which are positive, and neutrons, which have no charge. On the outside, we have these things called electron shells. And that there is my electron, and that is negatively charged. Does this hopefully ring a bell from what you guys have done previously? No? Oh, well then this is new stuff. That's okay. So when we say composed of atoms, this is what we're talking about with the atoms. It has protons, neutrons, and electrons. The protons and the neutrons are in the center of the cell, known as the nucleus. The electrons are in the outside of the cell, known as the electron shell. Are we good so far? All right, the other thing to think about when we talk about elements is when we look at the periodic table, I'm just going to shift this up a little bit. So you know how when you see things on a periodic table, you have these little blocks of stuff? And you say, for example, you see there's a C and there's an N, and that's for like carbon, for example, and that's nitrogen. So those are different elements, right? Now there's different information we can get on each one of those elements. You see two numbers. There's smaller numbers, like that 6 and that 7, and there's also bigger numbers like the 12 and the 14. So we should be able to decode all the information looking at that periodic table. So names of the elements are there. These letters are referring to as a symbol. So that symbol just is a shorthand way for us to call things. Now there's two different numbers there. The small number is the atomic number. Now that atomic number is something that's really important because that is the signature of the element. So it's unique to the element. And what that tells us is whatever the atomic number is, that is how many protons there is. So number of protons, and also the number of electrons. So if carbon has the atomic number of 6, how many protons should I expect? 6. How many electrons should I expect? 6 again. Yeah. With nitrogen, how many protons does it have? 7. Electrons, also 7. All right, these numbers on the bottom, the bigger numbers, those are referring to the atomic mass. And the atomic mass is talking about the number of protons plus the number of neutrons. So mass is just like what we think about mass is how much it weighs, how much matter is there. So it's basically whatever's in the nucleus is what we call the atomic mass. So if I have 6 protons, how many neutrons should I have to get to 12 as my mass? 6. Now that number may not match the atomic number, just for a lot of elements it does. All right, so that's what I want you guys to make sure you have written down in your notes as our first bit of information. I'll leave that up a little bit longer because I'm mindful some people are still writing. All right. Easier? So make sure oh yeah. Alright, can we move on to the next page?
Next page.
Alright, can I move it? Can I move it? Mixture. Alright, so the next thing we're writing down is the word mixture. Go to the next page, that's what I'm doing.
I told him it was just next and he said he thinks everything's here. Wait. What did you see?
Alright, a mixture is 2 or more substances, but they are not chemically bounded together, so they're not actually attached to each other. So for example, I could have a mixture of elements. So an element and an element. For example, like if I had hydrogen and helium, that's a mixture. I can also have a mixture of compounds. So compound and compound. Like if I had carbon dioxide and water, which would be CO2 and H2O. I could also have a mixture of an element and a compound. like water and hydrogen.
I thought you did the
Oh, really bad.
Yo,
That's what we just did. We went in the book a week for like that long.
So that's what mixtures are.
Something for this. Okay.
Yeah, so if I had an element and an element. So E is just referring to element examples. C is referring to compounds. E and C are referring to if I have a mixture of element and compound. And if I'm thinking about a pure substance, that only has one chemical. And that can be an element or a compound.